lucky to have friends sitting at the front there. And thanks everyone for coming back after the break. We're almost done with the conference. There's 2 talks left. I'm really excited for the next one. So even if you're not interested in mine, at least stay for the next one. But yeah, so I was briefly introduced, but my name's Gerard. I'm a staff full stack engineer at Socket. What we do is we're a cybersecurity startup, and we focus on finding malicious packages in our open source repositories. So when Carmen before was talking about managing your dependencies, we kind of help you make sure that they stay secure. So that's kind of like my job, but on the side, I'm an author, and I'm recently an instructor on front-end masters. I'm in general kind of a creative technologist, and I like to build weird stuff. So when I was introduced, we were talking about like white hacker, and usually in my job I kind of try to help people, but sometimes I go to the dark side where I don't try to hurt people, but I use tech to hack maybe in not such a good way. But I could have used the title Hacking Cars in JavaScript for this talk, because this is what we're going to learn to do. So if you are a front-end dev and you use JavaScript in the front end, you don't need any Node.js to do this. You can actually build tools to hack cars just with client-side JavaScript. So before I start with the whole thing, I just want to say that this is for educational purposes only. I built this to learn. It can also be used to do bad things, but I will not take any responsibility for what you decide to do. So I will repeat that later on when I'm going to show a demo towards the end of the talk. I will repeat that this is for educational purposes only. Wink, wink. Anyway, so it all started, if you were here last year and you watched my talk, but I'm going to explain if you were not here anyway. So it all started with looking into tracking airplanes. And I'm not talking about the websites that you can go on and you have maps of like flights and stuff. I was talking about physically being on my rooftop with an antenna and getting live data, basically waiting for a plane to fly above me and getting the live data that they broadcast. This data is public. It's nothing sensitive. It's more, the velocity, like speed, direction, and stuff like that. But it was pretty cool. It was basically, waiting for planes to pass by, and you just get live data and you decode it in the browser, all client-side. And to build this, I actually used an antenna or an SDR. That's called, stands for Software Defined Radio. And it's called the RTL SDR, the one that I was using. And it's only a receiver, so you can only receive data, and then you can visualize stuff in the browser and do what you want. But I was interested in transmitting data. So not in the case of airplanes, that is highly illegal, and I would be in prison by now if I was doing this, but just transmitting in general. It's like, okay, I wrote code to receive, now I'm interested in how transmitting works. So for this, I kind of had to move on from the RTL SDR, and instead, I bought a HackRF1. So that's an SDR that's a little bit more powerful, and it can both receive and transmit. And usually, it's used by pen testers in security when they want to test either physical security or stuff like that, and you can build some interesting things with it. And when I got it at first, I didn't really know, how it worked or what to do with it. So I started by downloading the software called Universal Radio Hacker. I think it's available on multiple platforms. So on my Mac, it works fine. You could try Linux or Windows. But what this software allows you to do, you plug your SDR into your computer, and then you connect to it. And you can receive, you can have a spectrum visualizer, and then you can record data, and you can play it, and you can also have some kind of binary analysis as well. And it looked pretty cool. It's like, okay, I can test with the device that I have, I can see the signal, I can, record it, but I had to download a piece of software for that, like, I don't want to. So I like the web, I, want to build stuff in the browser. So I spent quite a few months trying to figure out, can I actually do this all in client-side JavaScript? Well, yes, otherwise that would be a very short talk. So let's talk about how this is actually implemented. So it's probably, easier to start with receiving data. So first, we want to be able to see if our antenna can receive data, and then we'll go step by step from there. So in terms of receiving data, first of all, when you want to receive data, you have to indicate a frequency that you want to receive it at. And there's different ways that you can find the frequency of a device that you're using. Either you can do it my way, where you can use a flipper 0. So if you haven't heard of this, it's a little device that has a lot of sensors in it, and it can help you figure out the frequency at which nearby devices are operating. It's now illegal to have that in Canada because they thought that you could hack into cars. It's not really not basically no, but they freaked out and they just made it illegal anyway. So I don't know in which countries it's legal or not. I have one, and I mean, I'm fine for now. So, and usually the way that I experimented with my devices is that I was just playing with a device that basically I have like a doorbell. I'm going to do most of the demos with the doorbell. And if you hear this annoying sound, I don't know if that works. I don't know. Or maybe I turned it off. On, off. Wait. Yeah, that's very annoying. I can't stand this sound anymore. Like, I've just heard it so often. But and basically, when it's using, so it's a little button here, and it just transmits a signal to the doorbell, and I was able to listen to that with the flipper 0, and it just gave me the frequency right away. The easier way is to just look at the little pamphlet you get when you buy something. You know the docs we never read, so it's actually written on there as well. So you can do it like the easy way, or you can have fun with a flipper 0. But once you know the frequency, well, you actually have to write some code to connect your device to the browser. So we're using the WebUSB API. So the first step that you have to do is to call navigator.usb.requestDevice, and you can pass in certain filters if you want to isolate a specific device that you want to connect to. If you don't pass that, oh, there was a little, okay. If you don't pass the filters, you'll have a pop-up with like all the USB devices currently connected to your computer, but yeah, if we just want to isolate one, it's just easier. And if you're wondering, well, how do I find the vendor ID and the product ID? So if you're using Chrome, what you can do is if you go to Chrome://USB-internals, you actually have a list of the devices that have been connected to the browser before. And here I recognize my HackerF1, and there's the vendor ID and the product ID that I can then use in my code. Otherwise, in general, you can look for the specific specs online of the device that you bought, and it should be somewhere. Once you actually have specified a filter, you call the open method on the device, and then you have a configuration and an interface, and usually these are device specific. In general, with the devices I've been using, there was always kind of one configuration and one interface, so it wasn't really too hard. But again, if you don't really know what values to use there, if you go back to your USB internals in Chrome and you click on inspect, you have some data here, and here we have that, okay, the configuration is the number 1 and the interface is the number 0. So you can usually specify that. Otherwise here, I use the constant USB config standard that is in the official HackerF library. So that kind of was easy to confirm that it worked. So at this point, we're connected to the browser, but we're not doing anything else. And because we're working with an antenna, we have to specify a few different things. For example, a gain, and a sample rate, and a frequency. So let's go into doing that. There's more, but I'm not going to go into the whole thing. So in terms of gains, you have a couple ones, but we're going to use the low noise amplifier gain, and that will help us kind of extract the data that we're interested in, and will kind of like lower the noise, so that then we can work with our data a bit better. And when you try to configure a USB device with what you want, with the USB API, there's two methods, control transfer in and control transfer out. So when I started working on this, I had absolutely no idea how to actually talk to my HackerF and what to do. So this is probably going to be a bit annoying because I'm going to go between this code and the docs. But basically, I didn't even know, like, how do I know if I have to call control transfer in or control transfer out? So this is where I started looking into, I'm going to zoom in because it's just really small. In the official HackerF library in C, you can see that here in their method where they're setting the LNA gain, it's this thing here that we're interested in, if I can highlight. OK, this is not readable. So here we have a libUSB control transfer, and I'm like, well, what is this? So then I go to the docs of libUSB control transfer. And then I look, OK, so we have like a handle, but in the WebUSB API, we don't need to set that. We have a request type and request. And that's a bit weird, because the values are actually different. So here, the request type is vendor. That's usually standard with what I've been doing with WebUSB, and the recipient is the device. But here, the request is one that is set in the official library as well, so I can just reuse it. But here I was like, why is there value 0 and index value? That's pretty weird. So again, you know, if we look at here, we have, OK, our first parameter is USB device. Then the second is like the type of request, so the in instead of the out. And then we have like 0 value, and this, and this. And if you look at, oh, sorry, I breathe. Here, OK, so if you look at the order of the thing, if we have 1, 2, 3, 4, OK, so value is the 4th. And then what do we have? We have 1, 2, 3, 4. So value is 0. So then I'm setting that value to be 0. But then, OK, we go back. And the value after, so value number 5 is the value, and if we go back to lib, it is actually the index. And that's why I wrote like, okay, index is value. So it's a bit, you have to go back and forth being, okay, if it's the official, library for HackerRef, then I'll try to re-implement it the same way, but in JavaScript. And here, I just know that for the gain specifically, the value has to be between 0 and 40, and depending on what you're setting, you have to be in between a certain range. And here, the control transfer in takes a setting object as the first parameter, and the second one is the length. And first, I was like, what do I know what length I should write? So again, if we go back to the library, the length here is the last parameter before or the one before last, and if we hear, yeah, it is the length. So it's kind of like how I went about it, I went between the official library and then the docs, and then I tried to kind of write that in JavaScript. And you can see that then if we move on to a sample rate, it's a little bit different, where all of a sudden it's not control transfer in, it is control transfer out. And I have to do some data manipulation to create 32-bit integers and between the sample rate and the divider. So if that doesn't really make sense, it's fine. I've spent weeks on this, so I don't expect for you to like understand it in 5 seconds. But it's basically going between the docs and the code as well. So if we look at sample rate and we go to, I think it's this one, sample rate. Here they do the same as well, where the frequency is a 32-bit integer and then a divider, and they use the out, so control transfer out, and then 0, 0, and the parameter that we're passing, and this is what I'm doing here as well. So as long as I'm following the official SDK, but I'm using, the web USB API works a little bit differently, then I can set different things. And finally, we also set the frequency, where it's a bit the same thing as well. I followed the docs, and they were splitting values between two, where if I'm sending something on the frequency 433.92, then the first parameter is going to be 433, and the second one is going to be 92. I'm not exactly sure why, but they did it that way, so I followed. And it worked. So I was like, sometimes when I prototype, I have limited time, so if it works, I just stop. So at this point, we have just connected to the device, and we've set a few different settings, but we're not still doing anything. We're not receiving anything at the moment. So let's do that. So to start receiving, as I said, this device can receive and can transmit. So the first thing you need to do is to actually tell it we're in receiving mode. So I'm not going to show you exactly what that set transceiver mode function does, because it's the same thing, like control transfer out, and then the specific request, and whatever. And then we have a transfer function where with the web USB API, when you're ready to receive data, you have to call transfer in. And the number 1 is just the receiver, the number, like the integer to say I'm in receiving mode, so just the same as above. But then we're also passing a buffer size for how much data we want to get back. And if there is data that we're getting back, then we just have a callback function, and we are returning the result in a typed array. And then we're just like looping this function again and again to receive continuously. And then, when we are calling this function and we're getting data, then here I'm just logging it, but you can do whatever you want at this point. At this point, you're getting raw data from the antenna, and you can do fun stuff. And when I'll show you later in the demo, if you want to create graphs with Canvas, you have to actually then transform the data between the time domain to the frequency domain if you create a frequency graph. And for that, you can use an implementation of the fast Fourier transform in JavaScript, and you're passing it your data, and then you can use that data to display it in Canvas. And that will make more sense a bit later. But at this point, we have connected our device, then we are setting a few things, and we are receiving data live. So that's cool, but then what if I want to keep that data? So the second step is to record it. I want to receive that data, and I want to save it in a file on my computer. OK, so for this, we're going to use an API you might have used, which is the file system web API. So the first thing you need to do is you call the show open file picker method, and that will open a pop-up in your browser when you can see all your local files and you can pick one. Then you select the file that the user has selected, and you create a writable. So that will allow us to write content directly to a local file while we're receiving data from the antenna. OK, so now we've just selected, but then when you actually want to write that data, you use the writable file variable that you just stored your writable file in, and you call the write method, and you pass it your content, so your raw live data from the antenna. And if you want to stop, so if we want to not keep writing forever on our file, we can call the close function, and that will just, we can still receive data if we want, but we're not writing it to the file anymore. OK, so we have our receiving code, and then we added a little bit more with another web API to record that content. But if I record it, then I want to be able to like replay it. You know? So the third step is like then transmitting data. And again, it's kind of like we can reuse it's kind of with projects like building on top of each other. So we have first step, second step, and then the third one. And the third one is that because the file is saved into like the local files, I'm not going to show again, show open file picker and select the file. But once the user has reselected the file they actually want to play back, then instead of creating a writable, we're actually reading raw data from the file using the array buffer method. And then once we're getting that raw data, first I need to set the transmitter gain. And I'm not going to go because that's also control transfer out, blah, blah, blah. So, by now, hopefully you kind of understand, look at the docs at how it's implemented. And then we are, or I am at least, calling a start tx function that I created custom where I'm passing the raw data. And because this time we're in transmitting mode, not in receiving mode, we have to tell the device again, like, hey, now switch to transmitting mode. It can't receive and transmit at the same time. So you kind of need to switch. And here, this transfer method is a little bit different because I'm not continuously transferring. I just want to transfer once my data. And this time, instead of calling transfer in, I'm calling transfer out because I actually want to transfer out. And then number 2 is the transmit mode, and then the second argument is our data. OK, so I actually forgot what I have after. Oh, yes. So if we want to stop transmitting, you actually have to you have to kind of close it. So you set the transceiver mode to like off, so like stop transmitting. Yeah. OK, so now that I kind of showed you how I built it, or at least, very small code samples, I wanted to show what the app actually looks like. So that's just a screenshot in case it doesn't work. I'm like, look, it does. So I'm going to switch. And OK, I have a lot of things plugged into my computer, and sometimes I've had issues with that. So if we try, we go here. It's probably small. OK, I think that's going to probably mess up my canvas, but that's fine. So the first page that we have is the spectrum analyzer. So first I want to connect, and I have the little pop-up, and I have a filter on HackRF. I can't zoom on the actual pop-up, but it says HackRF1. So I'm going to connect to that. And I just have here, the frequency is 433.92. And this is because, again, this is what my device runs on. And actually, it turns out that it's something that quite a lot of devices run on. So it's been pretty easy for me. OK, so at first, there should be nothing unless there's something else operating on that frequency right now, which I did not check. But so if we start receiving, OK, there is nothing. And if I press, woo! OK, so at least we know that we're on the right frequency. So wait, just because, like, wait. I don't know if that. OK, I don't remember. I can't see. You hear it? Yeah, OK. No, just so that I'm not the only one who is annoyed by it. So if I try again, doo-doo, OK. So I kind of amplified it a little bit. It's like, OK. And then I can stop receiving, and if I do that, you don't see the graph anymore. But at least I can confirm, OK, 433.92, it works. I can receive it. Cool, cool. But now I want to record. Oops. OK. So if I go to record, OK, so the way I built this app, I need to refactor it. I don't want to connect every time I change mode, but for now, that's what it is. And I want to choose the file. So I'm going to pick a file, and I have a file called JSHeroes.txt. Yes, it warns you that it's going to start to edit local file, which I'm OK with. And then if I start recording, OK, so the visualization is a bit, I messed that up, but you'll see later, if I want to confirm that it works, that should have actually, I should now go to my transmit page, and I'm going to connect my HackRF. I'm going to choose the file again. Oh, actually, it hasn't finished saving, so let me just OK, JSHeroes text. I should see a visualization, OK, of the signal. So it's pretty big. I don't know what I did there, but at least you see that it worked. So like for a while, there's nothing, and then a lot of stuff. And then if I start transmitting, so I'm going to put the button down, hands up. And if I start transmitting, OK. OK, so at this point, technically, I kind of re-implemented most of what Universal Radio Hacker has. There's one more thing that I wanted to talk about, but I haven't finished it, so I'm going to show you unfinished work. But it's not going to work, so it's like... But what I wanted to be able to do is, so maybe when I have time to work on this, I want to be able to have a binary visualization of like the data, so then I can do reverse binary engineering, so I can know like what is this signal actually like. Does it need to send the whole thing or only some? So for now, I just have like you can select, and I want to then isolate that and just show the binary code, but no time. So for now, I'm not showing you that. Okay, so for now we have our 3 main features, but that's not it. Then I want to, okay. So I know that I was talking about, when I was building this at first, it's just easier to do it at home with a doorbell because I'm just at home trying stuff. But at first I thought, well, nobody's going to really relate to this, like who has that doorbell? And turns out that then I gave an in-person workshop like a fancy office building, and what do I see out of the elevator? Like this fucking button. And I was just like, what? It's like a fancy, like that was $2. Like the doorbell was $2, and I can't believe that businesses actually buy this. So let's say that in terms of like hacking that, I wouldn't have opened the door, but I could have been very annoying, like hiding in the bathroom, being like, nee, 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 and yeah. So it would have just been, it's just I'm a child sometimes, and it would have been very fun. But I didn't do it. I didn't have the stuff on me, and again, it would have been quite illegal for me to. I don't know if it's illegal to annoy people, but. It wouldn't have done something too bad. It would have just been, annoying. Okay, so I talked about hacking cars. So now I want to talk about jamming. And before I move on, I want to say again, educational purposes only, especially for that part, because the rest of what I built so far, nothing really illegal. It's a doorbell. It's mine. It's my house. It's my stuff. Like, it's fine. If I start to drive around the neighborhood, like jamming the doorbells, that would be probably a bit more illegal. But if it's just me, it's fine. Jamming, though, is not fun. And again, if it's jamming myself, it's fine. But if you try to have fun, at some point, one year, I was at a conference where someone was trying to jam the Wi-Fi. Nobody figured out why, but it was really annoying. So don't do that. But I'm going to try to talk about jamming it with emojis. So you have a car. We talked about hacking cars. So you have a little car. And when you press the button of your key fob, it sends, it sends a signal to your car, and it opens or closes the door. But you can think of the fact that, well, if I'm pressing the button and I record, like okay, let's say if I'm in the middle and someone presses a button and I record the signal, and if it was the same signal over and over again, then it means that somebody could leave and I would have recorded the signal and I could play it back. And that was a problem. That was actually the case before. I heard that the first rolling codes implementation was in 1995, so it means that maybe before 1995 it was the case. It was the same signal all the time, so people could actually easily hack into cars because you just needed to record the signal for open and close, and that was it. But after 1995, they implemented what's called rolling codes, which means that there is a certain specific set of codes that your car is kind of like waiting to receive from the key fob, but you can't send the same code twice simultaneously. So even if I'm next to a car and someone opens their door and I capture that signal, if I then replay it when they're not there, it's not going to work because the car has moved on. It's waiting for another code, basically. But there is a way around that, and this is called a roll jam attack. So a roll jam attack consists in jamming the car's receiver while you record the code transmitted by the key fob so it can be replayed. So again, if we talk about it in emojis, me in the middle. I'm the attacker in the middle between the car and the key and the car. So what I want to do is I want to listen to the code transmitted from the car, and I want to jam the car's receiver with my antenna so that the car does not receive the code, but I receive the code. And what's happening then is that then I can transmit the code that I received because the car has not yet received it, and then party, I can leave with the car. So it would not be, I have a demo, but obviously I can't do it on stage. I wish it could be like, and now, like it's just the car coming in. So I can't do that, but I have a video that I'm going to play. The quality is, like, the sound is a bit muffled and stuff, so hopefully you'll hear it. I can explain it after. It's just a 1-minute video, but of like a hacking car. Oh, the sound, yep. Okay, So we start by making sure that the car is locked, so it is locked. And then here I have kind of like a roll jam experiment where I have two HackRFs and I'm connecting the transmitter that's closer to the R's receiver, and I'm also connecting the receiver that's here. And I'm picking a file that I want to record the data from the key fob. And what I'm going to do, so I start transmitting, and at the same time I start recording, and I press the button. And as you, oh shit. Okay, now that's fine. So I pressed the opening button, and the car did not open because it was jammed. So if I now go into my transmitting page, and I connect my transmitter, and I open my file. Oh, the signal looks pretty good. And if I start transmitting, oh my god! Okay, that's it. Hacking cars in JavaScript. Anyway. All right, so you can see that in practice, it wouldn't really work because I'm like on the car with my computer and the antenna. So what you don't see here is that the second antenna is behind the laptop, and it's very close to where the receiver should be in the car. And that's usually how you like jam it. So here, the HackRF is like not powerful enough on its own to be able to transfer or to jam from a distance that's further away, but you can buy an amplifier, or there's other tools that you can buy that would allow you to do that from like further away. But first of all, as I was talking about, actually I did not say that usually you're supposed to ask people for consent when you do this. So this is not my car. This is actually Anjana's car. So this project would have not been possible if she had not just easily said like, sure, hack my car. So yeah, and also even this morning, I asked Sarah Vieira for the keys to the car that she's renting right now. And I went to the parking lot around lunchtime. I wasn't able to jam the car, but I was able to receive the signal of like her Mercedes. So if we just look at, I'm not going to transmit it because obviously the car's not here. But if I just show you what it looks like, it was funny. It was a pretty nice signal as well, where I recorded that, and then obviously because the car had already received the signal, I wasn't able to unlock the car. But like maybe if I figure out how to actually jam it, then I can open it. But Sarah reminded me I have your keys. But yes, so. So you can try that with different cars. Probably not a Tesla, because I think a Tesla you open it with your phone. But again, if you have a car and you want to try that on yourself, this is okay. You can do that. And if you want to use someone else's car, just know that there is a risk of desyncing the key fob, and then you'll have to figure out how to fix that. I didn't go that far because I just thought, we'll see. And that didn't happen. So it was all good. And yeah, so it wasn't my car, so I don't care. But also, I don't have a car. But it was a really fun experiment, and it kind of worked pretty well. But another thing that you can do, even if you don't have a car, it also works with garage doors. I don't have a garage either, so I might invite myself to someone else's place. But and the thing is, not all garage doors have rolling codes. So you could, if you are in a neighborhood where they don't have rolling codes, you could easily just like drive around and just open everybody's doors. And that is obviously very illegal as well, I'm just hypothetically speaking. But yeah, and not even garage doors, but if you have lights at home that you turn on with a little RF transmitter, then you could also hack people's like lights, like in the horror movies, where it's like, So you can do that as well. And again, educational purposes, it was mostly to learn how to use the HackRF, but it's really cool to know that you can rebuild a hacking tool that was developed in a totally different language and run that in the browser. So now you can just share a URL to someone who has a HackRF, and they can do that as well. So before I finish, I want to, slides? I just want to share a few resources. So I haven't had the time to write a blog post. I wanted to do this, but I've been busy. And I haven't open sourced the repository yet, but if you are interested, I'll be sharing it where I usually am, and otherwise there's some docs to the HackRF and Flip0 and things like that. But anyway, thank you very much for listening, and thanks JSHeroes for having me again.